AI keeps breaking new norms on computing in demand, in scale, and the answer isn't just bigger GPUs or just more of them. It ends up being specialized chips, specialized platforms, open standards, and increasingly the potential and the need for regional or even sovereign AI compute stacks. In this episode of Tech Threads, we sit down with Cesc Guim, who spent nearly 2 decades inside of Intel, has over 500 patents, and now the CEO of Openchip, a company based in Barcelona, actually driving some of the European AI initiatives. And he talks to us about chiplets, the memory wall, and why is Europe betting billions on owning its own AI stack.
Welcome to Tech Threads, Weaving the Intelligent Future, the podcast exploring the fast-paced world of technology. In each episode, we dive into the latest innovations in data movement, AI acceleration, and the transformative potential of chiplet technology. Join us as we explore the breakthroughs that shape the future of computing and hear from industry experts on what's coming next in the tech landscape.
Hello, and welcome to Tech Threads. I'm Nandan Nayampally, Chief Commercial Officer here at Baya Systems. And on this podcast, we weave together the trends in silicon, in systems, in connectivity, and the innovation with the help of the people building the next generation of compute. So if you follow Jensen Huang's and the NVIDIA CEO's 5-layer cake, the 2 fundamental pillars are power or energy and chips or silicon. And when you consider that, it's also clearly about energy efficient silicon and that is fit for purpose for AI, right? Today, we're digging into how AI is rewriting the rules of compute architecture, why specialized silicon and chiplets are taking over from traditional large monolithic chips, and what it really takes to build the next generation of regional or even sovereign open compute platforms in Europe. My guest has lived this from both sides. Nearly 2 decades inside Intel's architecture group, deep roots in the RISC-V ecosystem and the open hardware community, and now building Openchip, a European semiconductor IP company that's also now a Baya licensee. Please welcome Cesc Guim, CEO of Openchip Software Technologies.
Thank you, Nandan. Thank you, Baya, for inviting me into this discussion. And honestly, we're in a very interesting point of time now, as we will discuss through today, kind of discussion on the change of direction of the technology, how we're using system and AI, and it's a very interesting point of time where things are changing very fast, the way that we architect systems and technology. So thanks for inviting me to discuss today on such matters.
We're lucky to have you. And for those who are not aware, Cesc is a technologist, is a researcher, entrepreneur. He has a PhD in architecture and computer science. He spent 5 years at the Barcelona Supercomputing Center researching HPC with over 60 publications and several tutored PhDs. He then moved into Intel Product Group and then into the Intel Data Center and AI Group, where he'd been a senior principal engineer and chief system architect for the network and Edge, a center for Intel's Network and Edge CTO office. He holds over 500 patents and lead architect on multiple Intel products and a top Intel inventor all the way from 2019 to 2023. And since 2024, he has been the CEO of Openchip. So, Cesc, let's start with the big picture, right? You've watched compute evolve from inside Intel to now building effectively or leading your own company. What's the single biggest architectural shift you've seen in the last 5 years?
I think honestly, the part there are a couple of shifts that are important. One is on the technology trend on how do we design chips and design systems. And in that sense, what we've been clearly seeing is that you were talking about monolithic architectures. No? So it's clear that we've been going over the last years about growing the models, scaling the models, getting more beefy interconnects at the system level, having more power-hungry systems. But there is a point where this kind of scale of making models more complex, more sophisticated, doesn't work anymore because of like physics law and because of cost law and power law, no? And the fundamental shift is that we went from something like highly distributed, like 20 years ago with edge compute and with grid computing at that time. Now we went to the data center cloud, and over the last few years in AI, even becoming more predominant, where we increase the consumption of the systems by trying to address the scale-up problems. Now it is slightly different. Now we're seeing that the power does not scale anymore, and we need to think much better on how we design our solutions by really thinking at the use case level, how we can decompose big LLMs into more small LLMs, how there is a role of not only AI, but also interaction with other compute that needs to take some decisions, agents plus vector plus matrix. So now we're coming back to again to the challenge problem that we had 20 years ago in the concept of grid computing, that is disaggregating and connecting different pieces to make them more efficient. Now that thing is back, no? So now it's super interesting because that means that you really need to understand like the use cases at the system level, no? How these different elements interact together inside one chip, but also across the fabric. And the second big disruption that I think that we're seeing and we will see is the velocity, right? I work for 20 years in a big corporation, and basically the way that you design like technology in big corporations doesn't work in small companies because you don't have the same scale, because you don't have the same time to prove your technology. So that's a fundamental shift on how we design technology, and you're seeing that as part of the startup ecosystem in the last 10 years, no? And that can only be achieved by the fact that we have companies like that are highly specialized on the different parts of the chips and on the systems. And one of the key aspects of success of companies, in my humble opinion, is actually how you establish this network of companies working together to achieve this bigger goal. And also, in a nutshell, one is technology trend on from monolithic to distributed, and the second trend is on how you change execution and delivery of the products in time to market.
And so this is clear, right? I think this is a need for change. But if a lot of the AI infrastructure is still built around, let's say, hyperscaler economics, right? It's hey, buy more GPUs, buy more, or build a bigger cluster. How do you see that changing with these new approaches like Openchip is bringing to market?
Well, I think it's clear, no? Like when you look at the economics of the data center, like many of discussions that we have with data center owners, is that they start to see, like from workload perspective in the data centers, that is not like when, like maybe 5 years ago, computing the data center was maybe 80-90% dominated by GPU consumption. But now this trend is shifting. No? There are some of use cases that the data center owners are seeing shift between 50% GPU plus CPU type of workloads. And even if you zoom in with these workloads that go in accelerator parts, like some of them may require matrix acceleration, some others vector. So there's a fundamental shift also in the data center with the discussion that you have with partners, is like they're questioning whether like having an investment like 90% of the assets into GPU is something that they are willing to do, because also all the financial risk, no? So I honestly like see like from the ecosystem perspective that there is like truly a mindful change, that is not like there's a transition from a GPU centric type of architecture into something that is more GPU, CPU, NPU or XPU type of combination. And actually, if you look at the latest kind of some of the latest papers that were published in ICS, like by Jack Dongar and others, like where they say that now, like the way of the data centers that for HPC and AI built on 100% GPU, that has changed a lot, no, and will change more. So to your question, like there's not anymore like a single source of technology. Obviously, there are some big companies that are not mentioned here for neutrality, but some big players that they have GPUs are in the marketplace. But that's going to change as the use cases evolve to more heterogeneous kind of demand, as we are already seeing in the hyperscalers or data centers.
So I think you kind of segued well into the kind of specialized computing that is required, right? So you've also talked about what are the multiple types of compute engines that you might want to put together. So can you walk us through a specialized inference chip, let's say, what it looks like in Openchip's world? Is it is it a single chip SoC that connects with others? Is it a set of chiplets? What's on die? What's off die? What do you connect with, especially if you have partners helping you build this?
So it's kind of very, very interesting, no? Because like that's another trend that we're seeing in terms of change on doing the CPU architecture or chip architecture that's very different from how we used to do SoC designs like 5 or 10 years ago, is that now like the monolithic chip does not scale anymore because of like resiliency, because of yield and stuff like that, and also scale, no? Because like it's impossible, like the giant chips that we're doing, they scale in a monolithic manner. So that implies as well, like now, once you have to break down the monolithic chip in multiple small chips that are called chiplets, to your point, is now, okay, how this new Lego block type of way of doing chips allows me to scale my products in multiple ways of building different derivatives with the same chip. No, you can have 1 or 2 chiplets to derive one single product, or you can have 1 or 2 chiplets to derive then 10 different products. No, and here the part that is extremely important to your point is whether like you have like acceleration within one chiplet that you replicate multiple times to achieve different products, or you have different chiplets that basically you combine in different ways to serve different markets. No? And then each of those chiplets may have a specific functionalities. Today, in our case, like without getting too much deep into how do we do things, the approach that we're taking is try to combine like some of these acceleration technologies within one chiplet and have another chiplet that helps on the I/O connectivity. And basically, with these 2 ingredients or 3 ingredients, we combine them to do different types of management or the derived products. No, and there is no single way like to like no there is no one rule or one recipe that covers everything. But from our side, having one type or 2 types of chiplet that helps us to achieve like different products, like and with general acceleration mechanism for matrix multiplication helps us to achieve that. And here the one important aspect as well is connected to what you guys do, is like one super important aspect is, okay, now you have chiplets, and within one chiplet you have different components, accelerators, SPUs, whatsoever, and then you have to connect chiplets and manage the I/O within chiplets. So here the role of the interconnect is extremely important, because now you need that interconnect to provide high speed, reliable network that also allows you to interconnect like different types of protocols at the physical and at the control level. No, and that's where I think that first of all, chiplets in my opinion is mandatory. Like in acceleration in our case, we are focused on within the chiplets, but there's nothing that prevents us to kind of have a specialized chiplets, and maybe in the future we will see that. And the third one is that when you compose chiplet, it's extremely critical that you go deeper into the interconnectivity, because that's like moving bytes from one place to another, like the coherency that you have within chiplet, across chiplets. Those things are extremely important. I would say, even don't take me like too extreme with that, but are even more important rather than when you are placing the acceleration. No? Because now, if you have a good coherency space between the different compute elements, whereas they are accelerators or not, and you have the right level of interconnection, the right level of protocols to keep consistency, coherency, that's what you need to do. No? And having this flexibility to combine and match things is what actually I think is the most valuable thing for a company like ours.
Well, I thank you for doing some advertising for Baya right there, in terms of the complexity that we're also trying to solve. I think what you said is what we're seeing in the market. That's why I think there's a lot of synergy in how we are approaching it as well. Right? It's gets more complex. Data movement, memory wall becomes a real issue that we're trying to solve right together. Um, and chiplets are a mode of simplifying, reducing complexity, maybe to some extent, but at the same time, specialization and getting chiplets to work across also adds more design complexity, right? So in terms of that, I mean, we've kind of come up at it saying the software-based design flow, whether it's on die or a cross die, is kind of important, but I'm sure you've kind of done your own work on that. So how do you find that balance? I know tools will improve, we will all improve, but how do you find the balance in today's world, and what do you see in the future for this resolving complexity and scaling systems?
Now I'm going to be a little bit controversial here because I'm also
Go
being
for it.
controversial within my company. My gut feeling is that not today, but in 2 years down the road, like CPU architects and RTL engineers and stuff like that, they won't do coding anymore. Like, and I know that very like different like Anthropic and other like guys have said that, but I think it's different like to say that in the software domain and that saying that into the chip domain, no? Because we all know that RTL development, it's something that requires very kind of deep knowledge, and it's very like how you design the signals, the floor planning. It's not like something that with today's AI technology or tools technology you can do. But my feeling is that on the long run, like none of these guys will be replaced, but certainly the help that those tools provide to reduce risk, to reduce sidebugs, to reduce like gloss performance gloss jaws, like they are fundamental. Because at the end of the day, like the part that is, I mean, I'm telling to my team, it's quality over quantity. Because like today, you can generate like 100,000 lines of code with any AI Gen AI tool. So the part that is really, really important is that there is someone behind those tools that really makes sure that every single step that those tools do is correct. Then the automation part of it, why they should spend time on this, no? So that's why I think like the software tools to help out on the design on the different parts of the chips that we do, NOC design, like some other specialized IP that we may develop, like tools are gonna become the center there. It doesn't mean though that we kind of remove roles. It just means that to reduce, like, because you know, like if you are doing a chip design for something that is 1500 watts, that is a giant chip, like with thousands. I mean, it's very, very easy that manual development and stuff that is not automatic makes mistakes. So now if you combine the expertise of very senior people that knows things that can go wrong and can interact with those tools, and if those tools are mature enough to cover all these kind of exponential situations that may happen, I think that that's the way to go. Now, the question will be to see how technologies and tools will evolve in the next 2 years. I'm certainly sure that in the short run, there are some low-hanging fruits that we need to use. And in the case of like the NOC, no, like I spent like 7 years doing like interconnect design in my previous company. I was one of the lead architects there on doing coherency protocols. And man, like catching up bugs in the coherency between one home agent, system address decoder, and two like cores, it was taking weeks, like weeks, because you had to run simulation for weeks. Now, and sometimes we ended up saying, oh, this is like a very fundamental thing that we didn't catch. Those things like tools can catch it very fast, or they already catch it and they won't do the mistake again. No, so that's why I think it's a no-brainer for me. Like tool, it's a combination of people and tools. No, so that has to be. And my question is, like, where we will be in 2 years, or where you guys will be in 2 years. That's something very interesting that we'll have to see and monitor.
Oh, indeed, and I think we're thinking the same way, right? So AI is certainly making tools, pretty much all aspects of the design flow rethink itself, right? And there are startups doing that. There are standard companies doing that. And we're going the same way, right? So we have a lot of core knowledge on how to put together very efficient network on chip, software driven, how it's data driven, how does that actually go through? How do we use AI to kind of extend that? All of that work is ongoing, right? And it's moving fast. So I think the common thread is that you will have to use tools.
Yes. Yeah.
And you have to improve the tools with the help of AI to kind of go do that.
Yeah.
Right?
And
so
by
I
the
agree
way,
with you.
Nanda, and by the way, I'm not, when I was talking about tools, I was not talking about specifically Gen AI, because Gen AI is kind of the trending topic today. Like tools can be something very fundamental that they don't even use Gen AI because it's just a tool. It can be any type of mechanism. So I think in general, any automation that happens across this is fundamental.
Yeah. No, indeed. I think there's a lot of, as you said, right? People may not write code for all of this. It may be generated. So that aspect, but what plugs in to make all of that possible are the tools that are specialized for a lot of these things, right? And they may use AI in their own right. And that's kind of, I'll put you on the spot a little bit here, right? So clearly we've had a really good engagement over the last year plus. And so when you evaluated what you needed for your systems, right, you thought about, hey, we need to build networks that are more optimal, and we need to be able to build them across chiplets. So for the fabric layer or for the software layer, what were you looking for? And well, where are you today, right? And what do you think you'll need in the future?
So there are a couple, like two fundamental aspects that I think are relevant here, like without getting into many details, but I think the ones that are more critical for me, the first one is the scale, okay? And basically, like what we are looking for whenever it comes into the technology that you guys develop is something that allows us to scale in a large quantity within a chiplet, but across chiplets. And today that's a fundamental thing that not every industrial player is yet there, because like if you look at you can see that with the designs that are happening out there, like the chiplet count typically is not the one that we will see in 2 to 3 years, but we're developing products for 2 to 3 years. So the scale and the power is the first important one. And the second one, which is equally important, is really like the appetite for innovation and co-development. And why this is so critical is because, as you mentioned earlier, like there are many things that are being developed as we speak. Like the chiplet technology is there, and there are many OSATs, many manufacturers, manufacturing companies that they have that technology. But when it comes into the productization of the chiplets, there are still a lot of unknowns, no? And you need to have partners that they're willing to go into beyond the current kind of state of the art, and you need to do some level of not co-development, but how do you address challenges together, no? And this level of innovation, this level of deep know-how on the areas I was mentioning to you. Like I spent lots of years in the interconnect, so I can understand like the complexity behind that. That's the second fundamental thing for me to pick up a partner in this domain.
Yeah, and I think we're working through tooling. We're working through kind of the first generation of chiplets that are getting more serious. I don't think merchant chiplets have yet kind of become easy, right? So from your standpoint, for the ecosystem to develop, what are let's say, the fundamental, maybe items 1 and 2 that need to develop to ease the path for the broader ecosystem?
So for me, like when it talks to chiplet, there are two fundamental challenges or opportunities that I always like to think about opportunities, no? But I think that the first one is really the time to market. No, now if you look like in the past, no, when you were like taping out the chip, like okay, you tape out the chip, and then 1 or 2 quarters, 3 quarters later, if there is no respin, you have the thing out of the door and then you have to start working with the PCB manufacturers and blah blah blah. But now the thing is that when you go into chiplets and the go to, and the post tape out kind of work, like now you start adding bunch of things in the middle, which may be things like tester wafing, chiplet test, wafer testing, chiplet testing, and now assembly, now SIP testing, and now you have to do the other things. So now in something that in theory helps the scale and helps kind of the economics. Now, when you look in the time to market, is like, oh shit, like, sorry for using like the word, but oh shit, I need, I'm actually like late. I mean, there are 1 or 2 quarters that I was not accounting on things that I need to do because of the extra things that I have to do, no, OSAT and stuff like that. And this thing is a big challenge, because now if you look that your product is gonna come 1 or 2 quarters later because of all those things, like you start doing the math, no, on the revenue that you are potentially, or market that you are potentially losing. So definitely, like, this is the priority number one that I think that the ecosystem has to work, and we know because we're working that in that there are different parts that they are doing, such that they are doing their kind of a strategy there. But fundamentally, the time to market is the first one. And the second one, which it relates to your wall actually, is like when we think about chiplets and we think about UCI, we just think about I'm moving bytes from here to here at certain speed with a certain power. But the reality is that when you start assembling chiplets from different companies, like now, guess what? Everyone has different power management techniques. Mm-hmm. Everyone has different telemetry mechanisms to access different quality of QoS mechanisms. So now, it looks like that we need some standard way to operate the chiplets and stuff like that. And it's true that there are some, I would say, initiatives that they're trying to look into it. But when you look in the reality where the chiplet ecosystem is today, is that if you want to connect chiplets from different companies, unless you do some pre-level of engagement on according how these things works out, that's going to be a Frankenstein that, the left hand doesn't know how to talk to the right hand and doesn't know how to put power in one leg and the other, and that's not going to work out. So I think like the second big challenge that we have in the ecosystem is to make sure that the chiplet becomes not only a physical and manufacturing standardization, but also on how these things talk together. No, and again on the interconnect wall, I think that you guys have a lot to say there.
Yeah, well, I think that's fair, right? And there's so many more exciting things coming up with wafer scale or CoWoS or multiple ways to kind of get there. So it's clearly headed down that direction. The key challenge is how does it work when it's not just a vertically integrated provider, but multiple providers, right? So that, I think you mentioned one thing that comes up both on the software side as well as on what we were talking about on the chiplet and the hardware side. So open standards, great in theory, has worked for open source software, even though then you still need a lot of players like Red Hat, etc., who have built out systems based on open source. So where do you see the real friction in the open standards today, especially in the AI world?
Well, that's a very tough question. I mean, I would say, like for me, and actually I will talk about what we are doing here in the context of Openchip. No, so like for me, is there are a couple of aspects. So the first one, as you know, like we're like focus on RISC-V based products, and we're working there because like we believe that we want to have like this degree of freedom, like to design chips, and that our customers can access not only to Openchip silicon, but also other providers that they provide a RISC-V based implementation, so that they can kind of pick and choose like different solutions. And I think like the first level of open source and standardization starts with the ISA. Now you go bottom up, no, and you have a RISC-V based implementation because as you know, obviously x86 is extremely mature. ARM, like they did their journey and is quite solid and mature now. Now, if you start with RISC-V, that is our bet in terms of an open ISA instruction set, and not open source, which people tend to confuse, but an open instruction set architecture. Now you go to the next level. No, the next level is like the basic tools, like operating system and stuff like that, and you have some level of support. Like in our case, so we're working with SUSE because he's an European player, and we're going together to define this stack. And now you start piling on top of it. No, like you have like Kubernetes and things like that. Now it's true that from RISC-V, for example, there are some initiatives like RISE that they are trying to unify kind of the different parts of the software stack to support open instruction sets. Now the question, the challenge, not the challenge, but I think that the next stage that we need to address is how we go from there to production systems. Because like now today, if you look at the major vendors that provide tools to enterprise, they're still not there. They need to do the journey. That's the first thing that I find that we need to work more on. And the second one is how do we work out with like, for example, like open source, like frameworks like LangGraph or things like that provide open source capabilities to build agentic workflows. How we enable those open tools or open frameworks on top of these open instruction sets. So I would say, like, maybe I'm not fully answering your question, but I think that we have the right kind of standards like in place and the right kind of organs in place, but the ecosystem itself need to work more on making those things at production at the system level and connecting all the different pieces. No, just to close on this, so one of the things that we're working on again with SUSE is a public announcement that we did. Is you have RISC-V based systems on the bottom. Now you have infrastructure management and operating system based on Kubernetes provided by SUSE, and then on top of that you have applications that run on agentic workflows. Now the question is, if your applications that you develop in Python run on top of LangGraph and things like that, and you manage to make those more frequent or more utilized agentic workflows run on RISC-V, now you are completing the whole stack. No? So I think that for in my opinion, and that's where we're trying to focus, is understand the full stack thing that you need in your system, who is working on those stacks in open source but in production manner, and start to work with the two of them. And then the ecosystems, like the standards, have to help and make sure that covers the needs that these different layers need.
No, that makes sense. And I think like from past history, right? I was at ARM during the path that took nearly a decade to get the software closer in the traditional data center sense. Obviously, the AI transition has been different, but also been easier for both x86 to some extent and ARM. RISC-V is coming in. I mean, it's kind of early in that process, but I think it's moving faster, right? You have to, I think, both. And also that's where the software development ease, et cetera, starts getting there, as long as standards are understood and accepted, right? And that also brings me to the next question, which is related, right? The US, China seem to have very strong built-up ecosystems that could be regional but are global, right? But you're building this system in Barcelona, and Europe is spending billions to try and build its own tech stack for AI, because it's becoming a source of both strength and weakness if you don't have the right solution. Right. So how real is the ambition there, and how do open standards fit into what you will need for the EU program to succeed?
So I think like one of the things that we, like as Europeans, we're I would say concerned of is not that much on all the technology ingredients that we have. Is really like on the full stack dependency that Europe has outside of it. I say it's like you're trying to win the Champions League, and now like the team, or well, let's say the World Cup, no, that now is World Cup, and now everyone that you need to recruit people from other countries to win the World Cup. No, and that's not that like you have the external dependency to do that. So I think that from our from European perspective, what we're trying to do is to make sure that for all the different kind of verticals or different the needs that we have from technology perspective at the product level, at the system level, we have some level of autonomy so that we don't depend on things like supply chain. Like, okay, I need my data center. I need to fulfill a data center from a healthcare perspective, full of racks for doing A, Y, and Z. Now, if I don't have my supplier that maybe outside of Europe, like my priority on the list will be very low. No? But now, how do I diminish my risk here and have European suppliers that are capable to provide my supply chain? So from that perspective, there are two aspects. The first one is if you want to be like truly like sovereign in terms of the technologies that you deploy in your infrastructure. Now, the first thing that you need to do is to be autonomous on the APIs that you use to access to your systems. And the APIs have to be based on the standards. Because at the point that your API depends on someone else owning that API, that can be a contract, that is a software contract or hardware contract, like when this API, this contract with these two type of APIs is blocked for whatever reason it is, it can be supply chain, it can be like many different things, now you're stuck, no? So from that sense, that's the first aspect is, okay, if you want to build like sovereign solutions, they have to be based on a standard to break this first level of dependency. And to that point, like one of the things that I'm challenging my team and in general is like for us as Openchip, we will be successful at the point whether we have our customers deploying their current solutions in our systems and they have no idea that they are using our systems or an American system or a Chinese system. When that happens, and that will imply that comes with an equal quality of service, competitive cost, competitive reliability, and etc., that's where we want to be. Okay, so that's the aspect number one. Open standards that you democratize the access to compute. Now, the second thing is how you get there, because one of the things that I said was, and that was on purpose. Like you have to be competitive. You can't compare. It's very like aspirationally. You could say, okay, I'm gonna do like an innovation project. I will have an SIP. I will put that like 1 or 2 racks, and that's going to be our ambition. But no, our ambition is really like to be able to help and maybe not procure 100% of the data center, maybe 20, 30%. I don't know, that we will see where we end up. But basically, to get to that point and have something that is production ready, is TCO competitive, has all the functionalities and reliability, the quality management system, all the ISOs and all those things, that now in terms of technology, you need to think out of the box. And obviously we know that Europe has not all the different elements. So that's when it comes like the global partnership becomes a must for any company, not only Openchip. So now, as long as you build your system with these open APIs that abstract the customers with the technology underneath, now the next level is, okay, I need to provide a competitive car. So I will do my car with the components that help me to get there. Obviously, I need to focus on the car design. I need to develop the IP that is the key IP for that car. I need to work on all these extremely complex parts of the value chains. But now you're focusing on the car. You don't focus on the wheels or on the steering wheel. Now what you have is you get some of these aspects that you don't focus on. You get the partnerships to get those things, and now you focus on the system or the SAP design. And now maybe over time, like depending on how things go, now you can change parts of the technology. But now, as your API is an open API, like from the customer perspective, you don't put the customer on risk, no. So I think that why it's super important that when you look at the global scale and this kind of sovereign access to the competitive, and I want to say competitive solutions, you need to combine the open APIs plus the best-in-class solutions that you put in your products, no? And that these are the ingredients that you need to move over time. And then obviously, like we know that the geopolitics and the global ecosystem is changing a lot. One thing that is not going to change is the lack of supply chain. That's something that also that's where we can help. but obviously like on how you interact, how you work with ecosystems to get the best in class solution, that's something that any company has to do.
So just to kind of confirm, the intent, as you say, right, is less about building walls as much as building competence or excellence.
Yeah.
Right. So that way you are competing with and not as beholden to. That also gives effectively economic benefits of having competition for even if it's not Openchip per se, but the customer or the enterprise benefits by having local competition, global competition to make things better.
Yeah, and I think that global walls in general, they are. I mean, but again, that's I'm not speaking up in behalf of Europe whatsoever. But my personal experience is always like these synergies across the globe always help. And by a matter of fact, so they're like we're talking about some technology components, but if you look at the materials that are used to build the silicon, like rare minerals and stuff like that. Like if you start from the fundamentals of how we build technologies today, like it's impossible that you do things that are based on 100% walls. No, so I think we always have to find the right balance to make sure that we are capable to deliver technologies that are useful to the customers.
That makes sense. So I think time flies when you're having fun, right? So we need to wrap this up. So I might ask you a very quick question with a hopefully short answer. Open hardware, is that mainstream in 5 years or still niche, you think?
Are you sure it's a short answer?
That's why I wanted to keep it short. Like
no, I think I think it that requires like some years to talk through it. But I think like again, open hardware is always will be relevant because it's going to allow us to, especially at the API contracts, because if we don't have this open hardware kind of APIs to allow interoperability across different providers, that's not going to fly. No, and I think that the more the ecosystem builds technology, this interconnect or interlock between technologies will be needed. So the open hardware, in one shape or another, will be required.
And that's absolutely true, right? Because it's a non-trivial answer to that. And as we wrap up this conversation, is there something you want to tell our listeners on how to follow up on Openchip's work, where to look?
I mean, you can follow us like LinkedIn. I mean, we are very passionate, so we try to be vocal. I think what I would say, like for me, and I was in a graduation ceremony, kind of doing the speech there. I would say that I've been like multiple decades here, and I think that now we're in a very interesting point of time where technology is doing breakthroughs in many different aspects, not on the maybe non like design perspective, but at the system. So it's a very exciting times. So let's talk again maybe in 2 or 3 years, and let's watch again our video and see how many things have changed in 2 or 3 years.
Indeed, and looking forward to our kind of joint success. Cesc, thanks for joining us right on Tech Threads, and for anyone else who's listening and wrestling with the kind of data movement problems like Openchip is working with. That's where Baya, Weave IP, and the software is helping solve it. So come look at us as well at bayasystems.com. And that's it for now. Thank you so much.
Thank you, folks. Thank you, Nandan and team, for inviting us here.
Thank you for listening to Tech Threads, Weaving the Intelligent Future podcast. Join us monthly for insights into the evolving tech landscape and the future of chiplet technology. If you enjoyed today's episode, don't forget to subscribe and share it with your network, and stay tuned for more expert discussions. Let's weave the intelligent future together.